Greetings! Alex McLean again with another video. This time, discussing, instead of one species, a group of dinosaurs. The topic for today was chosen by my friend Ali Bowersox, who has been a long-time supporter, constantly watching my videos, and was given the opportunity to choose the topic and decided to choose Ornithomimids. Now, rather than one species, I know that this is a focus on Appalachian dinosaurs because they don't get enough attention. I'll get to why we don't have a whole video here on one species in a bit, but I wanted to give a shout out to my friend Ali, as she has been not only a constant supporter, but also a commentator, and she's an artist who does her own webcomic. I will put a link below this video for anyone interested. And as another dinosaur fan, she wanted to learn more about bird mimics, or Ornithomimids. Now, Ornithomimids get their name because one Othniel Charles Marsh, who my paleontology fans might remember from the Dinosaur Bone Wars, he was the first person to do a scientific evaluation of the bones discovered by one George Cannon in Colorado and John Bell Hatcher in Montana. Two separate scientists, two separate locations, discovered these new dinosaur bones. And so Marsh named them Ornithomimids, or bird mimics, because the bones were hollow and looked like large birds. And he named the first of this new group of dinosaurs Ornithomimus, or bird mimic. And based on the amount of material we have of Ornithomimids from around the world, the sizes we have of them, and we have preservation from whole skeletons to bits and pieces, they were a highly successful group of dinosaurs. And they range from size. The smallest one, when fully grown, was about 3 feet tall and was called a Pelicanomimus, or pelican mimic. And the largest known was Dinosaurus, which is about the size of an elephant. And therefore, it was a highly successful group, both filling large size ranges as well as territory. And their bones have been found in New Jersey, Mongolia, Canada, possibly East Africa and Australia. Those two are in contention, though. Alabama, Georgia, North Carolina. So, wide-ranging group of organisms. And there is a noted preservational bias, even though they're widespread, for seasonal environments, because most of the skeletons have been found in river and lake sediments, which had seasonal climates. And there typically tends to be very little material in prehistoric desert and arid environments. So, there's also a very interesting preservation that Struthiomimus, Archaeornithomimus, and Ornithomimus have been found buried in groups, which, if you remember my previous videos on Appalachisaurus, and I think I also covered this a bit in Lotheropton, that is a pretty good indication for social behavior. And getting to the physical appearance of an Ornithomimid, typically they all have rather large eyes, large brain cases, rather flexible necks with multivertebrae, kind of like a swan's neck, which you can see there, bipedal. They also have long arms with, now the fingers, by the way, would not be, the wrist and fingers not pronated like in this specimen. That's a problem that most Jurassic Park dinosaurs have, solely the fact that, you know, you don't want to chalk it up to an error in the cloning procedure, be my guess, but I think it was an oversight. It's never fixed in the original film. But somewhat dexterous fingers, not nearly as much as raptors, but they would be semi-lunal carpals as well. And much like modern birds, there is a great deal of evidence, direct and indirect, these guys are covered in feathers, which sadly is something that this video game does not do, again, because it's dinosaur cloning and they throw that it's, you know, a throwback and they're not going to bother to change. But there is evidence that on the ulnas of these creatures, for those wondering, that's the distal arm bone at pointing down. There's believed to be long feathers attached to it, kind of like in modern ostriches. So possibly had some sort of display feature. And these are not flight feathers, by the way. They are insulation, possibly other communication, but it could be a way that these animals had territorial disputes. They could have been communication methods, etc. Much like, again, modern ratites that they convergently evolved to be similar to. And these, of course, are the ostrich, rhea, emu, and cassowary that are alive today. Those are the ratites. Now, again, these, because they are convergently evolved, we make certain inferences based on modern animals. But we're pretty sure on this one, again, because some groups have been buried together in groups. We know they had feathers, and they have rather large brains, large eyes, for dinosaurs. Now, as to why this video is a little different from the other two I've done that focused on a specific species, again, it's a preservational bias issue. As noted, Ornithomimid bones are hollow. They have a gracile body. And that means that there's a greater chance that the body is going to be broken apart upon death, and very unlikely in Appalachia to be well preserved. You know, going back, there's not as much material because bones are really, really hollow. These guys are built for speed and agility. They're not built for, you know, like tanks and such. And they don't have a lot of body mass to begin with, so it can easily rot away. Also, the top predator at the time, Appalachia, being a tyrannosaur, could easily break an ornithomimid skeleton apart to get its calcium, much like Tyrannosaurus rex would break apart the bones of its prey. So, preservation of bias, chemically, its own physiology, predators that lived in its environment. We don't have a whole lot of unique material of ornithomimids in Appalachia. We do have material, but it's almost exclusively incomplete. So, now, as I said, many have been found in Appalachia, and I couldn't give a whole video on just one scientific group because there's not enough evidence. And this goes to a whole naming issue, which is handled by the International Commission on Zoological Nomenclature, where all organisms have to have a binomial name and fit certain criteria to be unique. With fossils, it's inferred by material on the bones. We don't have genetic material. At least we have amino acids, we don't have DNA. Especially not of ornithomimids in Appalachia. And because of the need of a binomial name that's part Latin, part Greek, can be Latinized or Greek-modified modern words like, say, Appalachiosaurus or Albertosaurus. But it has to follow certain guidelines, and this species, unfortunately, has been called into question a couple of times. The specific species of ornithomimid in Appalachia is called Coelurosaurus antiquus, which I'm using a Struthiomimus as a filler, because they are quite similar. And it was found in 1865, originally by Dr. Joseph Leedy, New Jersey in the Navesink Formation, and the name means ancient hollow lizard, because much like Marsh, you know, top of bones were very hollow. And the problem is he could only identify it as a theropod, which, yes, this organism is grouped with theropods, which is the group of dinosaurs that includes all predatory dinosaurs, such as tyrannosaurs, allosaurs, raptors, etc. And, you know, it doesn't seem like, but it's, if you look at the skeleton, it is a theropod. But he couldn't get much further than that. Didn't have enough material. And because of this, the taxa was called into question a few times, including by Dr. Jack Horner and Donald Breyer in 1967, that compared the material found in New Jersey to known fossil material and determined that it wasn't its own species, that it belonged in Ornithomimimus antiquus. It did not have enough material to be its own species, Coelurosaurus. And later, in 2004, that Coelurosaurus classification was called into question again by Dr. David B. Wishample, from the Johns Hopkins University School of Medicine Center for Functional Anatomy and Evolution, and again declared there wasn't enough material between Saurolosaurus and Ornithomimids to derive its own name, but it is still considered an official species. And specimens have been found in Alabama, North Carolina, Maryland, and Georgia. That is said, unfortunately, all that material has been found as scattered bits that we know is an Ornithomimid, but we don't have enough material to build a complete specimen uniquely for this group. So Struthiomimus is the closest in size and relation that we know of used as a fill-in. And another Ornithomimosaur, though, in Appalachia, that has gotten more material, more press, and which does have more to report on, if I can find that little guy. Let's see. Here we go. Yep, here we go. Arkansas, the official dinosaur of Arkansas. Here. As for the color, I want to give a shout out to my friend Anika, who is a Razorback fan from Arkansas. This is the closest I could get to red for her. So, this one's for you, Anika. Hope you enjoy. I'm going to close out that video, or that little tab for the video, so I get a better look at this guy. I'm just using him as a different species. It is not because Archaeornithomimid is identical to it, like the Struthiomimus with Saurolosaurus. It's solely the fact I didn't want to just have a whole bunch of Struthiomimus in this enclosure. And again, this one had a better redder color. So anyway, Arkansas Friday was found. The material was found in 1972 by one Joe B. Friday, who ran a gas station along Arkansas Highway 24 near Locksburg, Arkansas, and had noticed in the highway construction and repair that this material had been thrown out as garbage, and he saw these bones and brought it back to his gas station, put it on display. Well, one university professor of University of Arkansas, Doy Zachary Jr., who was the geology professor, by the way, and lived near there, decided to take this specimen to the University of Arkansas and show it to his colleague with the consent, by the way, of the Friday family. He didn't steal it. The consent by the Friday family to have it looked at by one Dr. James H. Quinn, who was the paleontologist at the university, and immediately determined, yes, these were dinosaur bones. And even though this material was found in 1972, the species was not officially acknowledged as a fully acknowledged real species until 1998, with a publication of the work by Angela K. Braden, and was adopted by the state of Arkansas as the official species in 2017 by the work of one Governor Asha Hutchinson. And to understand, though, this was a placeholder name for a long time, because to be a fully recognized species, not only do you have to be unique, you also have to be published on and recognized. So it was what was called a nonum dundum, yeah, essentially a holding name. So it got published on in 2007 or in 2018, though, with the first journal article by the paleontologists Rebecca Hunt Foster and James Harrison Quinn in the Journal of Paleontology. The journal article titled "A New Ornithomimosaur from the Lower Cretaceous Trinity Group, Arkansas," and based on the age of the specimen, comparing it to other Ornithomimosaurs at the time, it was believed to be not only a basal member, but one of the first Ornithomimosaurs to officially found in North America. And this is important because at the time, most Ornithomimosaurs, which is the broader group containing Ornithomimids, were found in Asia. So this is a really good, important find to try to figure out how these dinosaurs got from Asia to North America and when that happened. Similar to how recent discoveries of Utah and such of Tyrannosaurs, saying the clock back millions of years, from when they originally thought to be in North America. So anyway, and to clarify terminology, lower is a geologic term and is related to geologic sequencing of a formation or a period in geologic time. This is due to the law of superposition, that younger rocks are on top of older rocks, and the law of original horizontality, which states that all sedimentary formations originally were deposited in horizontal layers. Afterward, yes, they can be folded, and you can wind up that you'll have older material on top of younger material just because the layers got pushed on top of each other. But in its original position, these hold true, and these are some of the founding bases of geologic science, thanks to the work of Nicholas Steno, who actually helped create the science of geology, along with other things. So, lower is a geologic term because it's lower in the formation, and early would be the chronologic equivalent. And this is an important distinction because when describing the bones, it would be lower, that's where the bones are found, whereas the animal lived in the early Cretaceous. Everyone on track here? Good. And there was an attempt, by the way, to go back and get more material of Archensaurus back in 1973, but unfortunately, because it was throwaway from road construction, there was no evidence of where exactly the bones were pulled from. There just wasn't any, and it's highly likely that the material was transported far from where it was dug up, just to get out of the way where the road was being cut, on top of the fact that the road probably buried the actual material. So there wasn't any way to go in and try to find it, and you're not going to get somebody to agree to dig up miles of pre-existing road, blindly looking for the chance of more dinosaur bones without a clear idea where it is. Especially, it's not fair to the taxpayer. It's blindly looking, interrupts a lot of people's lives, and it's really expensive to do this. So, sadly, more material would be great to find, but we're happy that we found the material we did. But this is one of the important aspects of paleontology. Where was this found? So we can find more material. And thankfully, though, the Friday family donated it, as I said, to the University of Arkansas. They got I think they made 4 casts of fossil material, which consisted of lower leg bones, and I think also a few toe claws. And they had to display that in their gas station and get the species named after them. So, all in all, it's actually very good news. So, going back to, Ornithomimids, due to a large quantity and quality of specimens as well as trace fossils, we do have a very clear picture of Ornithomimids, not just what they look like, but also certain social behavior. And one of the cool things about Ornithomimids is, much like modern birds, they use what are called gastroliths, meaning stomach stones. Now, certain dinosaurs had been inferred to have gastroliths, such as sauropods, but there was also the chance that these stones were just washed into the body by the very river that preserved the specimens. So it wasn't linked to any organs. Ornithomimids, though, specifically ones found in the, I am probably going to butcher this, Ulanshuhan Formation in China, discovered in 1997, were not in a highly moved river delta environment, but also these specimens preserved fossilized traces of their organs, including the gizzard, which those of you who know birds know where I'm going here. So the researchers, whom, out of respect to the fact that there's no way I can pronounce their names properly, I will simply say the title of the journal that they published in 1999, titled Herbivorous Diet in Ornithomimid Dinosaurs, detailed that they studied the pebbles in the preserved fossil gizzard. The organs, by the way, are long gone, but the imprint of the gizzard. They studied the shape, the chemical makeup, and the size of it, and compared modern living birds, such as chickens and others, I think also the radites that also use gastroliths, compared them to the gastroliths found in the gizzards, or should I say the pebbles at the point, found in the gizzards of these Ornithomimids. Turns out, based on the classification system of sedimentary material, angular, subangular, rounded, very, essentially the shape of the pebble. It's very specific, and again, chemistry and size, it was determined these were gastroliths based on the graphing of what the sediments found deliberately chosen by birds were with these pebbles found in the fossil gizzard. Now, again, sediments are classified, I think it's very angular, angular, subangular, subrounded, rounded, well-rounded. The term is about the shape of the grain and its size. These stones, by the way, are used to help digest because Ornithomimids, much like modern radites, don't have any teeth in their beak, and they don't really have powerful jaws. They let stones do the work for them to physically break up the material. And these stones have to be replaced regularly because, one, they're physically getting pummeled by the things like seeds and plant debris, and possibly these guys are believed to be omnivores, so possibly insects and whatever other stuff that they're grinding up. So they're chemically getting eroded as well with stomach juices, as well as physically pummeled. So they're passing through the digestive tract of these dinosaurs, so have to be replaced much again like modern birds. For those who take care of chickens, you have to have certain pebbles and such for chickens to use for their gizzards. So it's really cool because, one, this means convergent evolution, this form works great, and two, being able to save mineral deposits rather than having to build calcium even though it looks like these are teeth, by the way, that's just it's supposed to be a keratinous beak. It does not actually have teeth in its mouth. So it was an energy material saving adaptation for omnivory. And also a great way of convergent evolution between birds and dinosaurs. And after this study publication, by the way, gastroliths have been found in many ornithomimids across the world. Again, the imprint of organs is kind of rare, but we do find them in ornithomimids, and it's been confirmed not just in China but around the world, so you can infer that they were doing this in Appalachia as well. Let's see. Now, with ornithomimids, we also can estimate their speed. Not just being able to say, oh, this one looks fast. I mean, we're actually capable of finding ornithomimid footprint tracks. If I can get the camera to agree with me and be able to focus on these guys again, rather than just looking around at trees. There we go. So we actually can calculate the speed of these guys based on calculations of their footprint, calculating the length of the stride, the height of their hip, and creating a ratio between it that we know the length of the dinosaur's foot, we can calculate the length of its hip, which for theropods is usually like a 4.5 ratio. And we know what the footprint of an ornithomimid looks like, finding the feet, as well as how different they are from, say, a carnivorous theropod living in the same ecology. Differences in the ratios between the toes, differences in the foot pad, which you can kind of see if you look. I know it might not be that clear, I can't zoom any further. If you look at when the animal has been raising its foot up, you see that pad at the back of its toes? That's a cushion pad. And we, much like in radites today, they had cushion pads. I think emus are probably the best analog, because ostriches don't have the same, they have 2 toes rather than 3 toes. But you can see kind of a little pad we can look and see an ornithomimid's foot, calculate length of it to its hip, calculate the stride length, which is going from one foot, other foot, how long it takes for it to cycle through, and calculate that ratio. We can determine if it's running and calculate how far the stride length is. You can actually map out the speed, and these guys were running like 45 miles an hour and could maintain it. That, 45 miles an hour and being able to maintain it for long distances, not just sprinting, but you got a 4-chamber heart, air sacs, and a light body. So much like modern ostriches, emus, etc., these guys could run distance at high speed. So, look up the emu wars. If you ever had a question about, how fast an emus can go, the Australian Army during the Great Depression went to war with the emu and lost. So, they were using machine guns, by the way. So, these distant related ancestors are probably just as tough. Now, remember I said we don't really have footprints in the eastern side of the United States. Clarify, we have some footprint fossils of dinosaurs, but we don't have the high-quality footprints of Laramidia in Appalachia. And we do have some from the Jurassic period, we do have some Cretaceous settings, but we don't have the same type of trackways in Appalachia, but we do have some, and in fact, one of the first connections between dinosaurs and birds was their footprints, discovered by a minister, that he did work on dinosaur footprints. He thought they were giant birds. Okay, good. You can see now the ground's cleared. You see that bottom of the foot, its pad? Yeah, we can tell the difference between ornithomimid feet and theropod or other theropod feet, between ornithomimids or an ornithopod based on foot, the padding, and everything else. So we can tell the difference between them. So we're pretty good. We have concrete proof these guys are running 45 miles an hour. So getting back to the whole footprint thing, we do have, as I said, footprint fossils, but they're not the same quality, not as abundant. But we do have them, and I wanted to bring that point up, that it was one of the important links between dinosaurs and birds, found well before we thought that dinosaurs and birds were inextricably linked. Let me let those guys take care of that sick dino. So, and this gets us to what are called ichthyofossils. I just want to touch on this briefly. Ichthyofossils are, rather than body material, they're fossils of dinosaur activity. And these are important for understanding and interpreting the world of dinosaurs. Yeah, there's more dinosaur fossils than just skeletons. Footprints are vitally important because you can have footprints preserved even though you have no body fossils. You can have, you can't really tell speed without actual evidence, and fossil footprints allow you to determine speed, gait, the position of the skeleton, in fact, because it allows you to say a gauge measurement for where the legs are, where the shoulders are actually put, how much meat is on the body that rather than skin wrapping. So that's extremely important for dinosaur interpretation, and we have a lot of them from Ornithomimids. Now, last bit I always like to cover is dinosaurs in media and representations. And ornithomimids have a lot of representation.
Task received.
Let me see if I can get this dinosaur healed before the disease spreads any further. They have a lot of representation in media and in museums. And going back to the 1940s, the first theatrical appearance of an ornithomimid was Ornithomimus in Disney's Fantasia's Rite of Spring. That after you see the sauropods feeding, you'll see an actual flock of ornithomimids that they are feeding on some sort of plant material and drinking out the side of a river. And Fantasia had some really good ideas. They actually had social behavior, but of course the tails are down and a couple other things that no longer are thought of as accurate. But shout outs to Fantasia for that forward-thinking group behavior. And they're also been found in other, like cartoons. Okay, so, as I said, last bit that I like to go over is in media. Now, with Ornithomimids, I'll wrap this up. They have a lot of displays. They have a lot of preservation in media. As I said, cartoons going back, even like Justice League had them. In one episode, you have Dinosaur Train, Disney's Dinosaurs. In movies, they have been displayed a lot. And infamous, or rather I should say famous, not infamous, the Gallimimus scene in the first Jurassic Park film, those are Ornithomimids. If you remember, Dr. Grant ran with the kids to try to escape a T-Rex that was hunting the flock of Gallimimus. That was pretty cutting edge at the time. It's actually possibly accurate. That these animals would group together, much like modern birds, as a numeric defense against predation. If you're amongst a number of, others, less likely you as an individual is going to be attacked. So you group together and unlucky one might die, but the group survives. There was also, in Jurassic World, there were a few there, in the opening view of the park, that possibly, I think they had them looking a little weaker because it was supposed to be the fact they're all clones and just using the same clone DNA. Kind of as an indication the fact that, they weren't breeding, they weren't able to strengthen their genetic line, and copies of a copy of a copy. So inexorably they would wind up dying out and not being healthy enough to survive on their own because, they don't have genetic drift and, whole importance of having two different genders for reproduction and all those details. But they were there. And there's hardly a museum that doesn't have these guys. There's hardly a museum that doesn't have some sort of ornithomimid, if it has any dinosaurs at all. Even the McWane Center in Birmingham has a full-size ornithomimid dinosaur. I think it's based on Gallimimus. Just guessing by size, I don't think it's a Struthiomimus. I think it's a little too tall, and being hunted by a pack of Deinonychus-like raptors, which we do know existed in Appalachia. So they're widespread, and a lot of representation. And so I want to go back and thank Allie for her continued support, her constant assistance and belief in me, and want to give a shout out to Anika for your state dinosaur. So for Allie, she asked me to give a link to her current webcomic project called Huxon. It's a Dungeons & Dragons style universe with adorable artwork, cute plot, and the link to which will be below the video. So if any of my watchers have a moment, it would mean a lot to her if you'd give her comic a shot. And any comments, any questions are always appreciated. Sorry for this video being a little longer. There's a whole lot of material. As I said, this is about a group of dinosaurs rather than one species. So, any questions you have, feel free to ask. Any comments, any critiques, I'm always open to. Thank you very much for your time. Have a great rest of your day. See you next time when I will hopefully be discussing another topic of Appalachian dinosaurs. If you want to choose the topic, you feel free to comment below. I will honestly give it a shot, but only if it's about Appalachian type dinosaurs or species in Appalachia. Have a great day.